So now we will be seeing the gradient descent algorithm. Yeah. Let's recap what we have studied during the logistic regression. Then we will start the explanation of the gradient descent. So in logistic regression, we had seen that the predicted output y hat should be equal to sigma of W transpose X plus B, which is nothing but this W transpose X plus B can be represented as W as Z, okay, which is nothing but the activation function which you are putting for the last layer or last hidden layer, which is nothing but equal to 1 by 1 plus E4 minus Z. Now, this 1 by 1 plus E4 minus Z is the activation function which is put into the final layer. Okay. Now, the cost function is calculated by J W comma B, which is nothing but 1 by M summation of I is equal to 1 to M and with the loss function. And if we elaborate the loss function, we get it as 1 by M summation of I is equal to 1 to M y I, okay, log y hat I plus 1 minus y I log 1 minus y hat I. Okay. And in the gradient descent, okay, so what we exactly want is how do we get the minimized cost? So this is what we are supposed to get. So we want to find W comma B, okay, that W comma B that minimizes J W comma B. Okay. Now let's consider this, okay, where J is W comma B and we initialize somewhere here W and B. Okay, W and B values. And what we are supposed to get is the minimum function, minimum cost function over here. Okay, and this is nothing but our convex function. A convex function. Okay, where you can see this J W comma B, okay, is surface above the, okay, is above this horizontal axis. That is W and B. This is W and B. It is above the horizontal axis. W and B. Okay. Now, when this is converted to a convex function, okay, so we get like this. Okay, where we have seen that this part, okay, where we are initializing the W comma B. Okay, here we initialize W comma B. Okay, now what does the gradient descent do? So gradient descent, what does it do is, okay, it finds out the path, okay, to go towards the minimum cost function. So the gradient descent does is that it takes you to that minimum cost function. So this is what, when I draw a straight line, okay, it makes me tend towards the min of J comma B, W comma B, okay, which is nothing but the global okay, optimum function. Okay, so in this way, gradient is purpose of illustration, purpose of, okay, tending towards, okay, and the minimum cost function is shown in this case. Okay, now the in programmatically this gradient descent, okay, is nothing but a function where we repeat the change in the, okay, the weight and the error rate. So what are we doing here is in gradient descent is W is equal to W minus alpha change in the weight, and that is change in the weight with respect to the, okay, change in the cost. Here alpha is nothing but the learning rate. Alpha is nothing but the learning rate which controls how bigger step we can take, and djw by dw is derivative or update we want to change to the parameter w. Okay, and this w is nothing but the initial w which we take. Okay, so in gradient descent w is nothing but the this initial weight minus the learning rate, and this is nothing but the derivative or update we want to change for the parameter w. Okay, so this parameter or the update with w is done with respect to the change in the cost what we would like to have, and alpha is nothing but it is learning, okay, that is how bigger step it is taking, okay, by tending towards the minimum cost. Okay, and this w is nothing but the initial value. Okay, so this keeps on continuing. So and it's a repeated function. So while writing in the code, we write it as w minus alpha dw. So we don't write it in this way. We write it alpha dw instead. Okay. So how does it work? So this is how it works. So this is my w, and this is nothing but consider my jw. Okay. So if this is my minimum cost function, okay. So if I'm going towards this side, okay, if I'm going towards this side, then it is nothing but can say that the change in the change in the cost function, change in the weight with respect to the cost function is greater than 0. Okay, and in this case, can say that change in the weight with respect to cost function is less than 0. So when it's going in this side, the change in the weight is less than 0. Here, when the change in the weight is greater than 0. Okay, now so when I'm taking the overall cost, that is j w comma b, so change in the weight, that is w is equal to w minus alpha okay, dw, and b is nothing but b minus alpha db, okay, because we are actually changing both the weights as well as the error, okay. So both these things are being considered, okay, for the gradient descent, okay. Now if you're finding the calculus part of this difficulty, so we'll go to the next video where I'll be explaining you about the calculus part of the video, okay. So if there is any doubt in this, thank you. We'll see, we'll discuss, okay, later. Thank you so much.